AP Chemistry Periodic Table Electron Affinities. Specifically, what we're going to look at today is the definition of electron affinity, electron affinity periodic trends, and anomalies involving electron affinity. Electron affinity is defined as the energy change associated with the gaining of an electron by an atom in the gaseous state, and we represent this with a delta H and a subscripted EA. Electron affinity is typically, but not always, negative because an atom or an ion usually releases energy when it gains an electron. So for example, if I have a chlorine atom with 7 valence electrons and it gains 1 electron, it's going to become a chlorine ion with its full octet and a lot more stable. In this case, the electron affinity is negative 349 kilojoules per 1 mole. When most atoms attract electrons, energy is released, so the sign of delta HEA is negative. Electrons that are added complete the element's octet and as a result increase stability. As a result of increasing stability, energy is released, and again we see a negative delta H. So the general trend of electron affinity is that it increases from left to right across a period, which makes sense as our metals are typically not going to gain electrons, but our nonmetals will gain electrons to get their full octet, and it's going to decrease down a group. Anomalies involving electron affinity. Groups 2, 15, and 18 have extremely low electron affinities. So the question is, why? Our elements in group 2 have filled s orbitals. Therefore, they're not really looking to gain electrons as that s orbital is filled. In group 15, each p orbital has 1 electron. Repulsive forces within each orbital does not encourage the addition of more electrons. A good example to look at here is something like nitrogen. Nitrogen has an electron configuration of 1s2, 2s2, and 2p3. So if we look at this p sublevel right here, and we imagine that it has its 3 orbitals, 1, 2, 3, that's a pretty stable configuration. Compared to oxygen, which would have a higher affinity, because again, if you think about oxygen, that is 1s2, 2s2, 2p4. So therefore, in this situation, we're going to have 1, 2, 3, 4. For nitrogen, here we have 1 electron in each orbital. And like I said before, this is pretty stable. If we add another electron in, there's going to be some repulsion between the 2 electrons. So the electron affinity is relatively low. We contrast that with oxygen. It has 4 electrons in this p sublevel. If it gains 2 more, it'll have its full octet. Therefore, it will have a higher electron affinity than nitrogen will. Finally, group 18. It has a filled noble gas shell, therefore a full octet, and it will have a very low electron affinity. So what did you learn? We went over the definition of electron affinity, we talked about electron affinity periodic trends, and then we looked at some anomalies involving electron affinity. Need more help? Feel free to contact me. Have a great day.